Welcome to Plutus Project-Based Learning 2023 from Gimbal Labs. Thank you for taking a look at this video. We're currently working on Module 202, 5 Ways to Mint a Token, and in this lesson, we will look at the second way to mint tokens. This time, we will mint native assets with native scripts using Cardano CLI. This video provides a walkthrough of how to create a native script, how to create a policy ID, and then how to use both of them together to build, sign, and submit a transaction that mints new tokens on Cardano pre-production testnet. You can follow along with the documentation below this video. As it says here, in this lesson, you will mint tokens that only you can mint. What makes it possible to mint tokens that only could have come from you? Well, just like you can create an address from a public key, which is what you saw in lesson 102.2, you can also create a policy ID using your public keys. A few notes to get us started. We're going to be using the word script a lot, and it's really important to distinguish between the different kinds of scripts. First, we have Cardano scripts, like native and Plutus scripts. And then we've got shell or bash scripts, and I recognize that it could get confusing to be talking about all of these at once. I promise to try to do my best to always distinguish between what sorts of scripts we are talking about, but I hope that you'll hold me and the rest of the Plutus PBL team to account and to make sure that we're being as clear as possible in defining which sorts of scripts we're talking about. Now, even when it comes to Cardano scripts, we have to make the distinction between native and Plutus scripts. And that's exactly what we're going to do over the course of the next few lessons. In this lesson, we'll look at native scripts. These are scripts that existed even before Plutus was live on Cardano and allowed us to create simple rules for how UTXOs could be unlocked and how tokens could be minted. We will also investigate Plutus scripts, which actually use Plutus validation to define when a token can and can't be minted. Both kinds of Cardano scripts can be used in Cardano transactions, and one thing we can do with them is mint new tokens. So, in this lesson, you'll create a native script, then you'll use it to build, sign, and submit a transaction that mints new tokens with a particular policy ID. Then, in lessons 4 and 5, you'll see how to compile Plutus scripts and use them in a similar way. Taking it step by step, here's what we're going to do. First, I'll show you how to create a native script, and you can follow along with this documentation. Then, we will calculate your public key hash and use it inside of the native script that we build in step 1. Then we'll learn how to generate a policy ID, and finally we'll use a provided shell script to mint some new tokens. Let's start at the top. I'm going to navigate over to my code editor and build a new directory for holding this new myfirstpolicy.script file. On my computer, I'm working in a directory called PPBL 2023, and this has 2 directories in it right now, PPBL 2023 Front-End Starter and PPBL 2023 Plutus Template. I'll make a new directory called Native Scripts, and then I'll cd into it. Then I'll create a new file called myfirstpolicy.script, and I'll open it up. There's our blank file. From the documentation, I'll copy this little bit right here. And that's the full contents of a really simple native script for Cardano. What this script says is that in order to use it, it will require a signature. And which signature? The one associated with this key hash or public key hash. Now, whose key hash is this? Well, in this case, it happens to be mine. But if you'd like to do this on your own, you'll have to replace this pub key hash with one that corresponds to your signing key. You can review lesson 102.2 to see how to create new public and private key files. Once you have those keys, you can run this command, Cardano CLI address key hash, and then the payment verification key file tag, and as an argument, you can pass it the payment.vkey file that you created in lesson 102.2. I'll navigate out of my native scripts directory and into the one that I created when I first made my example CLI wallet. This wallet has a public key and a private key. It has a particular address. I can copy this command just as it is because this directory has a file named payment.vkey. Let's try it. Great, there's a new pub key hash. I can copy it and replace the one that was originally provided. Now this policy script can only be used to mint tokens if the minting transaction is signed by this payment key right here, which is associated with the public key here that was used to create this pub key hash. I'll save this file. Before we keep going, let's talk for a moment about policy IDs. You now have a native script, but what native asset can it actually mint? In order to answer this question, you have to understand that on Cardano, every native asset has a policy ID, and every unique native asset can be defined by its policy ID and its token name. Here's what it looks like. If I run Cardano CLI query UTXO for a certain pre-prod address, I might see an output that looks like this. And over here, each of these represents a different token or a native asset. Before the dot is the policy ID. So in this first example right here, we can say that a native asset is defined like this, where the policy ID is the first part of this string, and the token name is the part that comes after the dot. This token name is a hex string, and I'll let you use whatever tool you'd like to try to decode it and see what the name of this token actually is. You could also just search for this policy ID on a website like preprod.cardanoscan.io, and you would be able to see both the readable text name of this token and the associated hex name. Every one of these policy IDs was uniquely generated from either a Plutus script or a native script. Tokens with a certain policy ID can only be minted if the rules in the associated script are met. So in this example, the rule says, well, a minting transaction must be signed by the private key associated with this public key hash. But there's other sorts of rules we can write. In the case of a native script, we can name the tokens whatever we would like. But one example of what a Plutus script allows us to do is specify precisely what names are allowed to be used in the minting of a token. That's one difference between Plutus and native scripts. A native script cannot set rules for the names of tokens, but a Plutus script can. We'll cover this point more in depth soon. With that background knowledge about policy IDs in mind, let's take the script that we just created and use it to generate a policy ID. I'll copy this command, but I can't use it from the example wallet folder. Watch this, because that script doesn't exist in this folder. So I'll have to navigate back to the native script directory I made a few minutes ago, which actually holds this script file. Let's run that command again, and sure enough, I can see a policy ID right here. This policy ID is derived from this native script file, and I can only ever mint tokens with this policy ID if this rule is followed. Finally, we can combine the policy ID that I just generated and the native script written earlier to build a minting transaction. In Mastery Assignment 102.1, linked right here, you saw for the first time how to send native assets in a transaction built with Cardano CLI. A minting transaction is pretty similar to this, with just a few more lines to specify minting. Here they are right here. We specify what we'd like to mint, and we specify the corresponding script file. If this policy ID matches this script file, the transaction will succeed. In the Plutus template that was introduced in Module 101, there's a new script file called minttokensnativescript.sh. This is a shell script. Let's use it to mint some tokens. I'll provide a quick line-by-line walkthrough of the script itself because shell scripts can be used as a form of documentation. And I'll provide a quick demonstration of how to use it. I'll head over to my code editor, and I should point out right now that I have a Cardano pre-production node running on this computer. So I'll be able to use Cardano CLI to build these transactions. Keep in mind that earlier in the course you learned how to use Demeter Run, and this repo right here, PPBL 2023 Plutus template, is the one that we initially used in Demeter Run. So if you navigate to VS Code in your Demeter instance, you can still pull the latest changes. Let's do that. I'll change directory into this one and run git pull just to make sure I have the latest copy of this code. And this git pull command will work the very same way in Demeter Run, as will all of the next steps we're about to do. Now, since I pulled the latest changes, I can see this new file right here, minttokensnativescript.sh. I'll open it up. And let's just read through here. This is an interactive script that puts some different messages in the terminal window. It prompts us for user input and eventually builds a transaction. This is what I'm most interested in, building a transaction that mints new tokens with whatever script I'd like. Notice that all of the most important values in this transaction build are variables. They've got the $sign in front of them. That's how variables are referenced if you're writing a shell script. And so everything above line 85 is serving both to show you what's happening in a step-by-step way and to set values for each of these variables. For example, the receiver address, the token name, and the number of tokens that will be minted are set in a series of prompts. And down below, we can see that the receiver and the quantity and, not the token name, the token hex are placed in the transaction build. Let's find token hex. Here it is. There's a little bit of bash magic right here that takes the token name from the user input, translates it to a hex string, and then this part right here just removes the return. Okay, so you basically tap enter or return after you enter a token name, and that's added to the end of this string. We don't want that. And that's what this little bit right here does. Then, once we have a token hex, we can use it in our asset ID. The policy ID is also calculated automatically by this bash script. Let's see how. Up at the top of the file, let's look for where, okay, policy ID comes from right here. This has a $sign and then some parentheses, and then a command inside of those parentheses. How does this work? Well, if you're writing a bash script, you can set as a variable the result of some other command. So you can see here that we prompt the user for the file path to some minting script. And then once we have it, we run that script through transaction policy ID, just like we did a few moments ago. We then store the result of calculating this policy ID as policy ID so we can use it later. And we use it a couple times. First, we just write a message to the user that they are going to mint this many of this token name with this policy ID. When we actually build the transaction, we say, yeah, we're going to mint tokens with that policy ID, and we're going to send them to some recipient. Note that in a minting transaction, this number right here has to match this number right here. In other words, I can't mint one number of tokens, but only send some of them. And in the very same way, I can't mint just one token, but try to send many of them to myself. Finally, a quick word on where we get the TXIN, the address, and the sender key. At the top of the file, I can see that the wallet we will use is a command line argument. So when I run this mint tokens native script, I have to supply it with the path to some wallet that I'm using right now. Then, from that path, we can look inside of that directory, we can get the payment address, we can get the path to a private key, and we could use this helper function called chooseWalletUTXO, which takes a wallet path as input, prompts the user to choose a UTXO, and returns the transaction hash and index of that UTXO. This function, chooseWalletUTXO, comes from a file called getTXFunction that's also in this directory. You could take a look at it right here. Now, you may or may not want to become an expert in writing bash scripts, and you don't have to. The purpose of what I'm showing you right now is to expose you to how this works and to show you that there's a really nice function here that you can just use instead of trying to write it yourself. Big shout out to Adrian for sharing this one with the team. So I've provided here a brief overview of this file. As you read it on your own and start to play around with it, if you have more questions about this shell script, be sure to bring those questions to live coding. Much more fun than just reading this code is actually using the script. So let's give it a try. I can change directory into the bash scripts folder. And now there is one more thing I have to do in order to make this and the other scripts in this folder work on my computer. I have to set up the private variables. Now, there's a file here called variables example. What I'll do is make a copy of it in the same directory. I'm going to rename it variables private because that's what's expected by this one and some of the other scripts in this folder. And then I'm going to set the values for each of these private variables. At minimum, I need to set the path to my Cardano node socket. And for added convenience, you can try adding your own address and path to your private key. For now, I'm just going to set this variable, and I'll do this part off screen because these are private variables. Okay, good. My private variables are now set. Remember that in order to use this script, mint tokens native script.sh, I must supply as a command line argument the path to my wallet folder, which is right here. So I'm in bash scripts right now. I should be able to type ... to go up one level to this directory, ... again to go up another level to my PPBL 2023 directory. And then I can start to type PPBL 2023 example wallet. I can see that when I press tab, it auto-completes, so it's finding this directory. And now I should be able to run this script. Let's see. So I pressed enter, and now I see an initial message, just like you can see in the script itself. So I read the message. I can press any key to continue. It says that I'll mint a token from this address right here. Now, is that the address I see in this payment.addr file? Looks like it ends in VWDLK. Yeah, that looks good. And that is the address I want to be minting from, because when I created this minting policy, I got the pub key hash of this payment.v key right here. So that's good. And then it says enter the path to the minting script. It's going to be up 2 directories in the native scripts folder, and the file name is myfirstpolicy.script. And I'll know if this works if I see a policy ID in just a moment. Okay, enter the pre-prod address. I could get a different address, but I'm just going to use the one right here. I'm going to mint these tokens and send them to myself. What's the name? Let's make these Sandbox 2 tokens. And how many do I want? I'll mint 99 this time. It could be anything. So now I get a confirmation message. It says you will mint 99 Sandbox 2 tokens with this policy ID. This should look similar to the policy ID I calculated earlier in this video. And just to be clear about where we are in the script, I've now made it to this message right here, and you can see that each of these 3 variables has been replaced with a value. All right, let's keep going. The last step is that we just have to choose a UTXO from this wallet right here, which we defined with our command line argument. 12.3 ADA should be plenty. So I'll pick row 1. And just like that, the rest of the script runs. You see, we get to this minting step. The transaction is built, signed, and submitted. We get this message if the build is successful. And at the submit step, we get this message if the transaction was successfully submitted. If I wait a few moments, after this transaction is confirmed on chain, I should be able to see these 99 new tokens if I query this address. Remember that there's a script provided for this as well called getAddressUTXOs, which takes a look at my private variables and takes a single command line argument, the address that I'd like to look up. So I should be able to say bash getAddressUTXO, and then where is that address? Here it is. Copy it and paste it. And it looks like there's now a third UTXO at this address, and it's got 99 of those new tokens I just created. Now, I didn't intend to cover this right now, but I see that something went wrong using this script on the computer I'm using right now. I can see that there's a policy ID right here, but I don't see the dot and the asset name following it. Now, it worked. It's possible, as you can see here, to mint a token without a name, but something's wrong with probably the way that this token hex is being calculated. I tested this script on a Linux machine. I was running the Ubuntu operating system, and it worked just fine. But now I'm on an old Mac using ZSH or Z shell, and it looks like some of the bash syntax in this script doesn't work on ZSH. That's good to know. But you know what? I'm going to leave this error in this video as encouragement to you. I'm still learning a lot of this stuff too, and teaching it gives me a chance to practice. So I hope that it's helpful to see this mistake, and this is something we can talk about at Live Coding, and I encourage you to try to troubleshoot. If you're using a Mac with ZSH like this, one thing you can do is just change the version of shell you're using from ZSH to bash. And another approach is just to write different versions of these functions right here. We could probably ask ChatGPT how to do it, or I could just search the web and figure it out. But the only reason this error happened is because we're trying to automate quite a bit, and the main point of this lesson is still here. This is what a minting transaction looks like. And you've now seen how to mint with a certain policy ID and a certain script file, and it works. One thing I'd like to do at Live Coding, in addition to troubleshooting this ZSH error right here, is also to show you some errors. What happens if I try to use a policy ID that doesn't correspond to this script? What happens if I try to sign the transaction with a key other than this one? Let's look at some of those things together in an upcoming session. I encourage you to try some of those ideas and some of the extensions at the end of this documentation on your own. All right, have fun out there, and see you soon.